Your engine starts idling rough. Then, the fuel economy drops. A few days later, you notice oil around the engine, and suddenly, the check engine light comes on. The mechanic mentions a mass airflow sensor, maybe a throttle body, maybe gaskets. And before you know it, you're staring at a repair estimate for hundreds, sometimes thousands of dollars. But here's what makes this dangerous. Several expensive-looking engine problems can begin with something far simpler, something most drivers never inspect. And the second problem I'm going to show you is even easier to miss, because you may not even know your engine has this breathing system at all. Before you replace another sensor, gasket, or intake component, check these two things first. Because if either one is wrong, your engine can look sick even when the expensive parts are perfectly fine. Let's start with the one everyone thinks they understand. The engine air filter. Most drivers know what it does. Air enters through the intake, passes through the filter, travels toward the throttle body, and eventually reaches the cylinders. Simple. But here's the mistake. A clean-looking air filter does not automatically mean your intake system is healthy, and that distinction matters. Because the filter itself is only one part of the system. The seal around it matters. The airbox matters. The intake tube matters. Every clamp between the filter and the engine matters. If dirty air can find a path around the filter, it doesn't matter how expensive the filter media is. The engine is still breathing contaminated air. And there's one clue you can look for that almost nobody checks. Remove the filter and inspect the clean side of the airbox, the side after the filter. It should be relatively clean. If you're seeing unusual dust trails, dirt collecting around the edges, or grime downstream of the filter, don't immediately blame the filter material. Look at how it fits. A slightly warped filter frame can leave a gap. A damaged airbox clip can prevent the housing from closing evenly. A poorly seated gasket can create a tiny bypass path. And tiny gaps matter because air always looks for the easiest way through. This is why simply buying the filter that promises the most airflow isn't always the smartest move. Your engine doesn't need maximum airflow at any cost. It needs enough airflow while keeping harmful contamination out. That's the balance. Filtration efficiency, restriction, dirt holding capacity, and sealing. All four matter. And here's where marketing can make things confusing. You'll see filters advertised as high flow, performance, reusable, premium, heavy duty. But one word on the box cannot tell you how well that filter will perform in your specific engine. Laboratory testing exists for a reason. Engine air filters can be evaluated under standardized conditions for airflow restriction, filtration efficiency, and dirt capacity. But even those numbers need context. Because if two filters were tested with different airflow rates, different housings, different dust, or different stopping points, you cannot simply compare the headline numbers and declare a winner. That's important because exaggerated filter comparisons are everywhere. One test gets turned into, "This filter destroys engines." Another gets turned into, "This filter doubles engine life." Real life is more complicated. But fortunately, you don't need a laboratory to find some of the most common problems. Your engine. Start with the basics. Filter fit, airbox seal, intake tube condition, loose clamps, cracks after the filter. Because here's something many drivers overlook. If a crack develops in the intake tube after the filter, the engine may pull in air that was never filtered at all. And depending on where that leak is located, the engine computer may also be seeing airflow that doesn't match what it expects. Now you can get poor idle quality, fuel trim problems, hesitation, check engine lights, and suddenly someone is pointing at the airflow sensor. But the sensor may only be reporting the problem. A trouble code tells you what the computer noticed. It does not always tell you what caused it. Remember that sentence, because it's going to matter even more with the second problem. And this is the one most drivers never think about. Your engine doesn't only need a controlled way for air to enter, it also needs a controlled way to manage pressure inside the crankcase. Every time combustion occurs inside a cylinder, the piston rings seal most of that pressure above the piston, but not absolutely all of it. A small amount of combustion gas can make its way past the rings and into the crankcase. That's called blow-by. Some blow-by is normal. Even a healthy engine produces it. But those gases can't simply remain trapped underneath the pistons. Pressure would build. Oil vapor would accumulate. Moisture and combustion byproducts would remain inside the engine. So manufacturers use a crankcase ventilation system. You may know part of it as the PCV system. And this is where a lot of people misunderstand what's happening. Your engine does not necessarily have a second replaceable air filter. Some engines have a PCV valve. Others use diaphragms, oil separators, internal passages, breather hoses, or components built directly into the valve cover. The design changes from engine to engine, but the job remains the same. The crankcase has to breathe, and when that system becomes restricted or fails, something very interesting happens. Symptoms start appearing in completely different parts of the engine. First, crankcase pressure may rise. Now oil begins looking for weak points, maybe around the valve cover, maybe around seals, maybe through another ventilation path. So you see oil and assume bad gasket. And maybe the gasket really is leaking. But ask one more question. Why did it start leaking? If the crankcase is being pressurized because the ventilation system isn't working correctly, replacing the gasket might fix the visible leak without fixing the cause. And eventually, the problem can return. That's why good diagnosis isn't just about identifying the damaged part, it's about understanding what damaged it. Now imagine the ventilation system also affects airflow behavior. On many engines, crankcase vapors are routed back into the intake so they can be burned. If that system develops a leak, restriction, torn diaphragm, damaged hose, or failed valve, engine airflow can change. Now the idle might become unstable. Fuel trims may move. You could get a lean condition, maybe a whistle, maybe oil consumption, maybe hesitation. And here's the trap. Every symptom can point you toward a different expensive component. Oil leak? Replace the gasket. Rough idle? Clean the throttle body. Lean code? Check the airflow sensor. Oil in the intake? Maybe the turbo. And sometimes, one of those parts really is faulty. But when multiple symptoms appear together, experienced diagnosis asks a different question. What single failure could explain several of these symptoms at the same time? That question can save you a lot of money. Here's a simple example. Suppose your engine suddenly develops rough idle, increased oil consumption, and a strange whistling sound. Replacing 3 separate parts might be one approach. But on some engines, a failed PCV diaphragm could potentially contribute to all 3. That's why you inspect before you replace. Now, let's talk about what you can realistically check yourself. First, inspect the engine air filter. Don't just ask whether it's dirty, make sure it's the correct size. Make sure the frame isn't distorted. Check whether the seal makes full contact around the airbox. Look for leaves, debris, or something preventing the airbox from closing properly. Then, inspect the clean side. Look for suspicious dust trails. If dirt is getting around the edge, you've learned something important. Next, inspect the intake tubing after the filter. Look carefully around accordion-style rubber sections. These can crack between the folds where damage is difficult to see. Check clamps. Check connections. Look for disconnected vacuum or breather hoses. A leak you can barely see may still matter. Now, move to the crankcase ventilation system. And this is where I want you to avoid a common mistake. Don't watch one video showing a PCV valve on one engine and assume your car uses the same setup. Find the correct PCV layout for your exact engine. Your owner's information, factory service information, or a reliable repair manual can tell you where the ventilation components are located. Then, inspect the hoses. Are they cracked, collapsed, loose, full of sludge? Is there oil accumulating somewhere that doesn't look normal? And pay attention to sounds. A failed diaphragm or vacuum leak can sometimes create a whistle or unusual suction noise. But don't diagnose the engine from sound alone. Use it as a clue. Now, here's another important point. Some people recommend opening the oil cap while the engine is running and judging the PCV system by how much pressure or suction they feel. That can provide a clue on certain engines. But there is no universal oil cap test that diagnoses every vehicle correctly. Some engines naturally run noticeable crankcase vacuum. Others behave differently. So if something looks extreme, investigate further instead of declaring the diagnosis finished. And here's the part that can prevent an even bigger mistake. Suppose you find excessive crankcase pressure. You replace a ventilation component, but the pressure comes back. Now you need to consider another possibility. The ventilation problem may be the symptom, not the cause. Remember blow-by? If the piston rings or cylinder walls are significantly worn, more combustion gas can escape into the crankcase. The ventilation system may then be asked to handle more gas than normal. So if a breather or separator keeps clogging rapidly, or crankcase pressure remains excessive even after the ventilation system checks out, don't keep throwing PCV parts at it. That's when proper testing becomes important. Compression testing, leak down testing, crankcase pressure measurement, oil consumption diagnosis. Because a $20 component cannot repair worn piston rings. And this is exactly why the diagnostic order matters. Start cheap and simple, but don't stay cheap and simple when the evidence tells you to go deeper. The same rule applies to oil analysis. You may hear that elevated silicon in used engine oil automatically means dirt is getting past your air filter. Sometimes, elevated silicon can support that theory, but not always. Certain sealants, engine repairs, and other materials can also contribute silicon. So one oil sample should not become a death sentence for your air filter. Look for patterns, not isolated numbers. That's the theme running through this entire video. One trouble code isn't always the diagnosis. One oil sample isn't always the diagnosis. One dirty component isn't always the diagnosis. You want multiple pieces of evidence pointing in the same direction. Now imagine you're dealing with rough idle and poor fuel economy. Before replacing a mass airflow sensor, check the air filter. Check whether the airbox closes correctly. Inspect the intake tubing. Check for leaks. Inspect the crankcase ventilation system. Then look at scan data. That's a much stronger diagnostic process than simply matching a code to a component. And here's why this matters more today than it did years ago. Modern engines are extremely dependent on accurate airflow control. Turbocharged engines, direct injection, electronic throttle bodies, sensitive fuel trim strategies. Small changes can affect several systems. So something as boring as a cracked hose can create symptoms that feel much bigger than the failed component. Simple parts can create complicated symptoms. That's probably the most valuable lesson in this entire video, because when people see complicated symptoms, they expect complicated repairs. But engines don't care how expensive the symptom looks. They only respond to physics. Air enters somewhere. Pressure escapes somewhere. Sensors measure what happens. The computer tries to compensate. And when one basic pathway stops behaving correctly, everything downstream starts reacting. So if your vehicle suddenly develops a rough idle, unexplained fuel economy loss, airflow codes, strange oil residue, or a new leak, don't immediately assume the worst. Start with this order. Number 1, inspect the engine air filter. Number 2, inspect the airbox and filter seal. Number 3, inspect the intake tube and clamps. Number 4, inspect the crankcase ventilation system for your specific engine. Number 5, use scan data and proper testing before replacing expensive components. And if the evidence starts pointing toward excessive internal engine wear, then investigate that properly. No guessing, no miracle filter, no magic valve. Just diagnosis in the correct order. Because the smartest repair isn't always the repair with the cheapest part. It's the repair that fixes the actual cause. And if you remember only one thing from this video, remember this. Your engine doesn't simply need air. It needs clean air entering through the correct path, and crankcase pressure leaving through the correct path. When either side fails, the symptoms can fool you. They can make a healthy sensor look bad. They can make a simple hose problem look like a fuel problem. And they can make a pressure issue look like nothing more than another leaking gasket. So before you approve the expensive repair, check how your engine is breathing, because the problem hiding in that airflow system might be small. But the bill you avoid could be anything but. Look